Do you want to learn how to make your own smart lock using Bluetooth? Then watch this tutorial from start to the very end. In this tutorial, you will also learn how to change the name and pairing code of the Bluetooth module. So the first part will cover the Bluetooth settings, and the second part will cover the circuit designing, soldering, interfacing, programming, and finally the testing. If you already know about the Bluetooth settings, then you can skip this part. So let's get started. Welcome back, my friends, and let's start with the Bluetooth settings. So the Bluetooth module that you can see on the screen is actually hc05. Well, it doesn't matter whether you are using hc06 or hc05, the basic function of both the modules is same. There is only a little bit difference in the AD commands, which I will show you once we will doing the Bluetooth settings. So as you can see on the screen, the upper pin is the state, RxD, TXT, ground, and the VCC, and the last one is the wake up pin. So in the first part we will be using the RxD, TXT, ground, VCC, and the wake up pin. So the wake up pin will be used for entering the Bluetooth module into the AD command, so which I will tell you when we will be doing the interfacing with the Arduino program. So before we are going to make the smart lock control system, so before that I will tell you how you can actually change the name of the Bluetooth module and how you can change the pairing code of the Bluetooth module. You can also use a default pin code, but in order to increase the security so that nobody else can connect with your Bluetooth module, so for that purpose I will tell you how you can change the pairing code of this particular module. So once we are done with the name setting and the pairing code, then we will use the cell phone to check whether the name is changed or not. So for that you will be needing an Android cell phone. First part, we need a cell phone and then a Bluetooth module and then Arduino Uno and a cable. So before you start the connections, first connect the Arduino and open a basic sketch which consists of only the white setup and white loop functions, and upload this. Now click the upload, and now as you can see here, now this sketch is uploaded. And now let's start the connections. Connect the VCC with a 5 and this one with the ground. The orange is the RxD pin, so connect this with the Rx pin, and the TX with the TX. And this is one extra wire which is connected with the 5 volt. As I told you that when we will be turning on the Bluetooth module, at that time we will connect this 5 volt with the wake up pin. So when we start the Arduino, it will enter into the AD command mode. So first, I'm not connecting this module. Let's check what happens if I just connect this. As you can see, the Bluetooth module is blinking fast and it's not in the AD command mode. So before you on the Arduino, at first you will have to connect the 5 volt wire with the wake up pin. So just hold it like this, and now just hold it for a second and then remove. Now as you can see, it's blinking slow, so it means that now it's ready, it's in the AD commands mode. Now let's open the serial monitor. So now let's check whether AD commands work or not. So write AD, yeah, it's working, AD, as you can see. Okay, now if you're using hc06, then you will have to enter the AD plus pin 1 2 3 4. This is the format. So you will just write AD plus pin and then the pin code which you want to set. Like for example, it can be any 4-digit number. and device name can be set through this command at plus name, and then directly write the name that you wanna write. But as I'm using hc05, so we will be using these commands. Now before you start the AD commands, you will have to do some settings. As you can see, the baud rate, which I have selected over here, 38400, and also select the NL and CR, which you have already selected. Now to find the pin code, enter 80 plus PSWD. So just write this 80 plus PSWD. Now the current pin code is 1234, and if I want to change the number, so how will do that? 80 plus PSWD is equal to any number, so like 80 plus PSWD is equal to, and this time I want to keep it 4321. It's the reverse one, and you can see that's okay. And now let's check 80 plus PSWD, and now you can see it's changed to 4321. And now let's change the name. For changing the name, this is the command. So just write 80 plus name equal to electronic clinic, and okay. So now let's connect this with cell phone. Close this, and okay, now restart it, reset the microcontroller, disconnect the Bluetooth module by removing the 5-volt wire, and now connect. So now it's blinking fast, it's not in the AT command mode. Now here's a cell phone, and open the Bluetooth, and let's search for this Bluetooth device. So now as you can see, its name is changed to electronic clinic, and now I just click on this, and now it's asking for the pairing code. Enter the pairing code, which is 4321, and click OK. So my friends, this is how we can set the name and the pairing code. So now it's time to start with the electronic lock. So this is the electronic lock that I will be using today, and well, actually I don't need this, so I will cut this and connect a DC socket so that I can easily power this up using a 12-volt adapter. So my friends, this is the complete circuit diagram of the Bluetooth smart lock, and this schematic is designed in CAD Eagle 6.3.0 professional version. So if you want to learn how to make schematics and PCBs, watch my tutorial. Okay, so first of all, let's start with the electronic lock. So as you know that the electronic lock has two wires. So the one wire is connected with the 12-volt, and the other wire is connected with the normally open of the relay, and the common wire is connected with the ground. And over here, as you can see, that the 10K resistor is connected with the base of the 2N222 transistor, and the other side of the 10K resistor is connected with pin 13 of the Arduino. So through pin number 13 we will turn on and off this electronic lock. So the 2N222 transistor, the emitter side is connected with the ground, and the collector is connected with the coil of the relay, and the other side of the relay coil is connected with 12 volts. It's a 12-volt SPDT type relay, and this is the common normally closed and the normally open. Now let's discuss the hc05 or hc06 Bluetooth device. So whether you are using hc06 or hc05, the programming and the circuit connections are exactly the same. So the ground of the hc05 or hc06 will be connected with the ground of the Arduino, and the RXT will be connected with pin number 8, and the TXT will be connected with pin number 7. So the Bluetooth module will be doing serial communication with the Arduino. So that's all. And one more thing, that the selection of the 2x2 transistor actually depends on the relay coil current. So when we will be designing the relay driver circuit, then at that time we will be doing all the calculations. So this is the basic circuit diagram, and now let's start the soldering. So now let's connect the DC socket. Okay, now our DC socket is connected, and now let's check this. Okay, this is 12 volts, and it's working just fine. Now let's start the relay driver circuit. It's a Vera board, and it is an SPHD relay. Now let's solder this. This is an NPN transistor, and the leftmost pin is the emitter, the middle one is the base, and the rightmost is the collector. And this is a 10K resistor, and I'm connecting this with the base. Okay, now the next step is, now I will connect the collector of the 2x2 transistor with the coil pin of the relay, and the emitter I will connect with the ground. So once I do these connections, then I will be back and explain this. So okay, now all the wires are connected. This is a 10K resistor which is connected with the base of 2x2 transistor, and this is the emitter, and this one is the collector. So as you can see, the collector is connected with one side of the relay coil. Okay, and the other side is connected with the positive, and the ground wire is connected with the emitter, and there is another wire which will be connected with the Arduino ground, and this wire is coming from here, and which will be connected to pin 13 of the Arduino. Through this wire we will turn on and turn off this relay. And there are two more wires, this one and this red wire, the blue and the red wires. So blue wire is connected with the common of the relay, and this one is connected with the normally open of the relay. So we will connect, so these are the two wires to which the electronic lock will be connected. So now I will do the interfacing. So my friends, as you can see, all the components are interfaced. This is the electronic lock, and this is the DC socket which we soldered, and this is the hc05 Bluetooth device. As in, you can see the VCC of the Bluetooth device is connected with 5 volt of the Arduino Uno, and the ground of the hc05 is connected with the ground of the Arduino Uno. And similarly, the RXD and the TXT pins are connected with pin 7 and 8 of the Arduino, and this is the relay driver circuit, and it is connected with pin number 13. So all the connections are as per the circuit diagrams which I already explained. So my friends, this is the code of the Bluetooth smart lock, and let's start with the #include software serial.h. This is the .h means that it's a header file, and the #include means that it's a preprocessor directive. So as we know that the Bluetooth will be doing serial communication with the Arduino, so that's why I'm defining pin 7 and 8 for the TX and RX pin of the Bluetooth module. As you know that in Arduino, we have only one serial port, and that is on pin number 0 and pin number 1. So right now I'm not going to use pin number 0 and 1 for the serial communication, as I'll be using those two pins for the debugging for serial communication with the computer, and I will use the pin number 7 and 8 for the communication with the Arduino. So now long integer data and integer relay equals to 13. So as I told you in the circuit diagram, that the electronic lock will be controlled with the help of the relay, and that relay will be controlled through a 5-volt signal from the Arduino. So this is pin number 13. A relay is connected over here, and with the relay an electronic lock will be connected. So we will be using two passwords. The one is the 555 and the other one is the 551. So if you want, you can use any other passwords for the security purpose, so that nobody can access your electronic lock. Now the every Mega and Arduino program has at least two functions. Those are the white setup and the white loop. White means that this function is not returning any value, and the empty parentheses means that this function is not taking any argument as the input, and similarly for this one. So when we turn on the microcontroller, the white setup function executes only one time, and over here we do like initial introductions. Like for example, if you're using a pin, then we will have to tell the compiler that whether that pin is an input or an output. So as we are using a relay, and this relay will be used for controlling the electronic lock, so this is an output device, so that's why it's output, and a pin mode function is used for this. So this is the pin name and then the output or input, and the digital write relay 1 low, so by default we keep it off. And serial.begin 9600 and blue.begin 9600. These are the baud rate bits per second. And there is a while loop. The while loop function then executes infinite time. So while blue.available equals to 0, it means that if there is no data, if there is no data received, then just wait over here and do nothing. If blue.available greater than 0, if the Bluetooth has received some characters or data from an Android application, then what to do? Data is equal to blue.parse integer, which is a function. So parse integer returns the first weighted long integer number from the serial buffer. And if data equals password, and for example I am pressing a button on the Android cell phone in an application, and I'm sending a password from there. So if the password received data, that will be stored in data. If data equals password 1, if the data received is equal to 555, then relay 1 high, switch on, and the door is open. So it will send you in feedback, and on the Android application you can see the door open. And if data equals password 2, and the password 2 is 551 to close the door, and so it will relay 1 low and then delay of 1000 and blue.write door close. So as a feedback it will send to you that the door is closed, which I will show you in the running. And now let's connect the power supplies and see this project in action. So let's start. So my friends, as you can see, the Arduino is connected with the laptop, and now I'm connecting 12-volt power supply, and also over here. So this 12-volt will be used for the electronic lock, and this 12-volt will be used for the relay energizing. Now as you can see, the Bluetooth is not connected as it's blinking at a fast rate. So now let's connect it. This is the smart lock application, Android application, and the password is admin. So the username and password are the same. Login, and now search for the peer devices, and this is the electronic clinic, and now we'll connect on the connect. So as you can see, now it's connected, and you can see it's working. and it's also giving me a feedback that the door is open and the door is closed. As you can see, I hope you like today's episode. Like my video, share my videos with your friends, and thanks for watching.